Hello all, welcome back with one another gate question. Just asking gate 2022. Here the question is something like this: to find the resolution of a particular address which is www.gate.org.in in the DNS server. Assume that there is no resource record or cached anywhere across the DNS server and the iterative query mechanism is used in the result. So basically there is nothing cached, means nothing is already present to you and you are using an iterative query mechanism, means one after another. Okay, so the number of DNS request query response pair is involved in completely resolving the DNS. So always remember, whenever we are having a DNS lookup, it will always do in bottom to top approach. Okay, so first of all, if you do www.gate.org.in, first of all, it will search for in. Within in, they will search for org. Within org, they will search for gate. And within gate, it will be searched for www or World Wide Web. So basically, there are basically four pairs of DNS query response. Okay, so we are asking the number of DNS query response pair. Okay, it's basically four. So they will iteratively check first of all for in, then org, then gate, then query. In this way, the entire execution will be happening. So our answer would be basically. So this question is also a very simple question. Okay, hope you understood this particular question. And this is all for this particular video. In the next video, we'll come back with the next question. Okay, all the best and good luck. Keep practicing. Thank you. So here in this particular series, we will be answering all the computer network questions, just asking gate control. Okay, so here on the screen, we are seeing the first question. Okay, so the question is: consider an enterprise. Okay, so consider an enterprise network with the two different elements, two different internet segments is given, a web server and a particular file connected via three routers as shown below. We are given three routers, one router, second router, third router. What is the number of subnets inside this enterprise? Okay, so we need to ask about these subnets. Subnets means this subnet. Okay, so here, whenever we say this is our firewall means this is our internal network. This is our enterprise internal network. So from here, it goes into one subnet. Here, it goes into a second subnet. Okay, so internally, it is divided into two different parts. This is the first subnet, this is the second. Not this first, this is second. Now, this second will prolong to here is the same particular subnet, and all of the system which is connected with this particular subnet will be a part of this subnet. Coming to the first subnet, the first subnet is further divided into two parts. This is 1.1 and this is 1.2. 1.1 is basically the web server, and 1.2 is basically the router, which is again prolonged to the entire internet. So always remember that the server, or you can say the subnets, is not divided at the internet. Okay, we are not divided at Ethernet. Okay, so basically, if you look here, we are having 1.1, 1.2 as two different subnets, and this is the 2, which is the 3 subnets. So in total, our answer would be, so in general, we have 3 subnets in this particular enterprise. The question tends to be very much simple, but with this diagram, it gets difficult to understand it. So try to understand always the subnet is divided by the router or by firewall or anything which is above router, but never with any particular device which is below the router. will be the network. Ethernet is basically a device of the data link layer, so they will not work in the subnet. Okay, so that's all for this particular video and this question. So this is the first question for the computer networking part. Hope you all liked it and let us know for any question. We'll be coming back in the next video with the next question. All the best and welcome back with one another GATE question, which was asked in GATE 22 from 2022 from the series of the computer networks. So here you are given a 100 Mbps link between the Earth station and the satellite receptor from the sender to the satellite at an altitude of 2100 kilometers. The signal propagation speed is also given. Time taken for the receiver to completely receive the packets of 100 bytes. That's what is being asked. So if you want to find the total time, it is ideally the sum of the transmission delay plus propagation delay plus queuing delay plus any particular type of intermediate. Okay, so transmission, propagation, queuing, okay, or any intermediate. Ideally, we try to, or intermediate is nothing but the processing. You can say any particular intermediate device using for processing. Ideally, these two we tend to ignore because it is the general case. They are given specified anything, we generally ignore it. It's a sum of the transmission delay and propagation. Now let's calculate transmission delay. Okay, so transmission delay is nothing but the length upon bandwidth. The length of the packet upon bandwidth. So length of the packet is 1000 bytes, so 1000 into 8 upon bandwidth, which is 100 Mbps. 100 into 10 to power 6. So if you say here, it would be basically 8 into 10 to power minus 5 seconds. They ask this particular total amount of data in milliseconds. So if you want to calculate in millisecond, it would be basically 8 into 0.08 into 10 to the power minus 3 seconds, which is 0.08 milliseconds. Similarly, if you want to calculate the propagation delay, which is distance upon speed. So distance is given as an altitude, which is 2100 kilometers into 10 to the power 3, which will be total meters. Why? Because the speed is also given in 3 in meters per second, 3 to 10 to the power 8 meters per second. Okay, so if you calculate this, it would be basically, you can calculate 10 to the power 5 in term if you want to calculate this in the terms of milliseconds. So this would be removed. So 300 divided by 700 divided by 2100 divided by 300, it would be 700. 700 into 10 to the power minus 2, so it will be becoming 7 milliseconds, which I am giving the direct to it. Okay. So the TP is 7 milliseconds and TD is 0.08 milliseconds. So here, if you calculate the data, it is 7 plus 0.08, which would be in total 7.08. So the total time which will take for the entire packet to reach from the sender to receiver, which is 7.0. The answer would be 7. So hope you understood this particular question quite well. This is a very simple question, and hope you were able to solve this question quite easily. Okay, all the best and good luck, and keep practicing this type of questions. That's all for this video. We'll be coming back in the next video with this question. Thank you. Welcome back with one another great question which was asked in GATE 2022 from the computer networking stream. So here you are given a data transfer of TCP using 1 Gbps. And the maximum segment transfer lifetime is 60 seconds. The minimum number of bits required for the sequence number field of the TCP header to prevent the sequence number space from wrapping around in the MSR. So basically, they are asking about what is the minimum bits size required for transferring byte space. Why byte specific? Because we all know that TCP, each sequence number carries 1. Okay, so here they are given per second. We are transferring 1 GB of data, which is 2 raised to 30 bits, which is 2 raised to 30 divided by 8 bytes. So if you talk about 60 seconds, we basically will be transferring 2 raised to 30 into 60 divided by 8 bytes. So this is our main formula, and this is equivalent to the number of sequence numbers. This many sequence number we require. If we want to transfer the data without any particular sequence number mismatch or any particular sequence number wrapping around, okay, for all the data. So let's try to identify how we can able to consider. So if we consider the number of bits required, so for that, so if you say the number of bits required is equal to, you can simply say log to the base 2 raised to 30 into 60 divided by 8, which is nothing but 30 plus log to the base to 60 and log to the base to 8 is basically. Now, if you consider the log to the base to 60, which is around log to the base to 64, which is basically, you can say around number which is 6, or you can have 5 point something minus 3. So you will have the value as 30. So 33 is the number of bits required. This is the bits required so that there are no any type of wrapping. There are no wrapping. So our answer is crystal clear. It would be 30 in this particular case. So that's all for this video. Hope you understood this particular video properly, or this particular question properly. So kindly try to solve this type of question as much as possible. All the best and good luck. Welcome back with one another GATE question, which was asked in GATE 2022. So here they have asked you about the considering the routing table of a particular organization, which is having a different subnet number and a subnet mask. Now they ask which of the following prefix in the CIDR notation collectively used to correctly aggregate all the subnets in the routing. So basically, which of these four can be combined and we can get all the subnets which is present in this particular routing. So first of all, we need to identify how many different subnets are there in the routing. Okay, and before that, let's confirm that this is an MSQ question. Why it is an MSQ question? Because which of them can be collectively used to correctly aggregate. So basically, we are asked about collectively, means we need to collect like some options, and we need to tell like which can aggregate all the subnets in the routing. Okay, so let's try to identify about the subnet number. So all the subnet number 12, 20, 164, 0, 12, 20, 170, 0, 12, 20, 168, 0, 12, 20, 166, 0. So basically, these are the four different subnet numbers, and the subnet mask is basically, you can say 255, 255, 252, and 0. So if you look here, 8 plus 8, 16 plus 6, which is 22. This mask is 22. Here, 8 plus 8, 16 plus 7, which is 23. Here also the mask is 23. Here also the mask is 20. So let's try to identify. So the first one, we have 12.20.164. So basically, all of these is the game of the third octet order. So let's try to identify what is there in the third octet 164. So 128 plus 32, which will make as 160. Okay, then we need to make 4, add 4. So 128, 64, 32, 16, 0, 8, 0, and 1 0. Okay, so if you look at first 22, so this is the, here we have this subnet, okay, which is 101001. Okay, if you look at the second one, we have 12.20.170. 170 means again it is 1010 in the first one, okay, which is 160. 160 plus you will have a data of 10. So 160 plus 10, which is 70, which is 170 total. So how will you make 128, 64, 32, 16, then 8, 1, then 0, 1, 0. So this is your entire subnet number, or you can say till here we are having the subnet number. Then we start with the host ID. Okay. If you look the third one, it is 12.20.168, which is again 1010. 1000. The last one is 12.20.166. Again 1010. And if you take 166 means 6 plus. Okay, so 8 is 0, 4 is 1, 1. So these are the different particular subnet numbers which we are getting. And in each and every case, we have 1010, 10, 101001. So these are the different subnets which we have. Okay, which I am highlighting here. Again, let's talk with the options. So if we talk about the option A, we have 12.20. We take 164. 164 is again 10100101, 10100100. Okay, but here the subnet is still here 101 because it is given jam 20. So 8 plus 8, 16 plus 4, 20. If you look at option number B, it is again 12.20.164. Again 10100100. But it is having jam 22, which is still here. Okay, 8 plus 8, 16 plus 6, 52. If you look at option C, again 12.20.164. If you look at 164, it is again the same thing. Okay, which is 1010 101001. Okay, again, if you look at here, it's basically of gem 21 to till here. Okay, it's 1010 then 0. And if you look at the option number D, it is again 12.20.168. Means again 1010 168 is this one, 100. Okay, so it is given as a gem of 22, so it will be looked up till 101010. Okay, yeah. And I made a small mistake, so these all are 23, 23. So it will be going till here, it will be going till here, it will be going till here. Okay, now if you try to look here, so see here, if you take the option A is only containing till 20, and here everything is from 22, 23, 23, 23. Okay, so if it's only containing 20, so basically it is having extra 2:4 different addresses. Here, if you look, it is again 22, which is same as this. So if you look, this 12.20.64.0 and 12.20.164.0. This is same. Okay, and this will, so 101001, 101001, 1010, here also 101001. So these both are covered here. See again 101001 and 101001, all are covered here because basically see here it's formatting the same font 101001, and this is both are having the same particular number of addresses also. Similarly, it is 10100. Okay, 101001, no, it's 1010 only. Again, having a more number of addresses. You look at here 101010, 101001 and 101010. So if you look till here, this both B and D, B covers basically 164 and 163 because 101001. So it covers first and fourth, while D covers second, which is 101010, 101010, second and fourth. Okay, so 1010. So highest, these two are the one which is maintaining it highest. Okay, in very easier way. If you look at option A, it's also having 1010. But here in the case of 1010, we are having a huge amount of other addresses. This can also be used to cover up 1010, 1010, 1010, all 10. But it is having extra addresses. Okay, even if you go 1010, 100, it will cover this one. It will not cover this. It will not cover this. It will cover this. So it will also cover this too, but again, it will have a huge number. So it's always beneficial to have all the same number of addresses which is given in the question, or somewhat less number of addresses, but the most optimal is given in the question. So here all four can be considered as an answer, but the most optimal one would be the one taking the least number of addresses. So if we look at 22, this is exactly matching with first. For 23, it is taking some more address, but it is better as compared to 20 and 21. Okay, so that's why it's been chosen. Similarly, here also it is having 22, 22. It is even, it is not same as 23, which you are having in these two, but better than 22 and 21. Sorry, 20 and 21. Okay, so that's why we are not choosing option A and C. We are only choosing the option B. So B and D collectively can able to handle all these different subnet masks. Okay, just look at the prefix first, and based on the prefix, you can able to easily identify that which one of them are matching. You just need to identify. Okay, first 16 are same in each and every one, but then you need to identify which one will match. Okay, so this question is little bit more confusing because here they haven't given any specific part. But if you look at it minutely with the particular bit level, you try to identify that they are following a particular pattern. And based on that particular pattern, we can able to easily get the answer quite. Okay, so that's all for this particular question. Kindly try to check and let me know in case of any problems. Okay, all the best and good luck. Keep practicing these type of questions. Good luck. Welcome back with one another GATE question, which was asked in GATE 2022, which related to the computer network series. So here we are having the three different routers where all the links have a cost of negative. So basically here for each and every particular link, we have a cost of 1. Now the router exchange the using the distance vector routing information and have converged on the routing table after which the link QR filled. So basically this link QR is filling after this particular router is converged. So basically from P to R the distance is 2. From Q to R the distance was 1. Okay, and somehow this is being converged. Somehow assume that P and Q send out routing table updates at random time, each at a same average rate. Means they are sending the at a random time at a average at the same average rate. The probability of the routing loop formation rounded off to the one decimal place between P and Q leading to count to infinity problem is what. So basically we have a connection from P to Q to R, where after some time this connection is failing, and count to infinity will happen first if P updates this particular information to Q first. So generally if P update first, we will definitely have a count to infinity. So let's identify all the possibilities. Here we can have the first common possibility is P update, sorry, just 1 minute. This seems to be an issue. So let's say P updates first. Okay, if P updates first to Q, it means what? That P is telling that there is a particular path to R via P. Okay, P will not update that this path is via Q only. So it will definitely cause a count to infinity problem. So this will cause a count to infinity problem.
Okay, this is the generic way of causing the counter infinity. Second case, which we can say is queue updates first, because both of them are updating at a random time, so anything can happen, right? So if this is the case, there won't be any count to infinity problem. As there is a happy path saying that if Q updates first, so P will update its routing table saying that there is no distance to R and there won't be any counter infinity problem. Okay. There can be a third scenario as well, both updates at same time. Now in this particular case, if both update at the same time, what will happen? First of all, let's say if Q update to P, there is no particular path to R. P update to Q that there is a particular path to R. Okay, so Q will update this particular information via P. Okay, but then after it will get to know eventually that there is no particular path to R, because see, Q has updated that particular path to R has infinity. Okay, sorry, P updated the path to R as infinity via Q, and Q updated the path to R as 2 via P. Okay, or 3 via P. But eventually, P will tell you in the next round that there is no particular path. So based on that, Q will also get to know that okay, there is no particular path present to R. So this will also not cause any particular counter infinity. Let me explain this once again. First, P update to Q and Q update to R at the same time. So P has said there is no path to R. Q has said that there is a particular path to R. Okay, via P, and the distance is 3. Okay, but then after in the next round, P will say that basically there is no particular path to R. Okay, so this is how the Q will updates about each particular thing. Okay, so that's a very simple way of doing this particular concept. So this will eventually, I can say this is not happening at the same time. This will eventually process correct data. Not in the initial part, but yeah, it will eventually process correct data. Okay, so you can say eventually there is no particular count to infinity. So we can say we have three scenarios, out of which only in the first scenario you will have count to infinity. In the next two scenario you want to be having count to infinity. So basically the probability of count to infinity is 1 by 3. So they have asked what is the probability of causing count to infinity. So out of three possibilities, the possibility of count to infinity is 1 by 3, which is basically 0.3. So the answer to this particular question, which is rounded up to one decimal place, would be basically 0.3. Okay, so hope you understood this particular question, and this is the end of the computer network series for the GATE 2022 question. Hope you understood it. All the best and good luck. Keep practicing this type of question. Thank you.